AP Calculus BC, Unit 8, Day 12, office hours. Here are the answers if you need to check them. 7, 8, 9's at the top, multiple choice. And 1 through 6 is on the front here. Pause the video if you need to. Check your answers. And number 6 says number of terms, n equals 4. It should go with 5 terms. Okay. All right, let's try these problems out. So first one is centered at 2, so we need to actually go ahead and build it. So the 0th derivative is the original function is x e to the x. We need to go to third order, so we need third derivative. This is going to be x e to the x plus e to the x, product rule. And then we get another product rule here, and it gives us x e to the x, another e to the x, and there's another e to the x, so there's 2 e to the x. And the third derivative is x e to the x plus 3e to the x. So then we're going to plug 2 into these. And 2e to the 2. 2e to the 2 plus e to the 2, which gives you 3e to the 2. 2e to the 2 plus 2e to the 2 gives you 4e to the 2. 2e to the 2 plus 3e to the 2 gives you 5e to the 2. So the third order Taylor polynomial, the first term is 2e to the 2 times x minus 2 to the 0 power over 0 factorial. It goes away. Plus 3e to the 2 x minus 2 to the first power over 1 factorial. Plus 4e to the 2 x minus 2 squared over 2 factorial. Plus 5e to the 2 x minus 2 to the third power over 3 factorial. There you go. Number 2, find the second derivative for this Taylor polynomial. So we know that means we should focus on this term because this term should be the second derivative 4 over 2 factorial though. Be careful. So the 5 right here is called the coefficient, but that includes the derivative and the factorial. So f double prime of 4 is going to equal 5 times 2 factorial. It's going to equal 10. All right. Okay, number 3, find the interval of convergence. Okay, well, we want to think of this as a over 1 minus r, and so the a is 10, the r is 2x, and the absolute value of r has to be less than 1 to converge, and that's how we find the interval of convergence. So it's going to be -1 to 1. It's going to be -1/2 to 1/2. Okay, if we find the Lagrange error bound, fourth order, so n equals 4, center to x equals 0 for this cosine function. So we need the fifth derivative. So the original function is cosine 3x. The first derivative is -3 sine 3x. The second derivative is -9 cosine 3x. The third derivative is +27 sine of 3x. The fourth derivative is 81 cosine of 3x. And the fifth derivative, which is what we need, is -243 sine of 3x. So The Lagrange error bound is the f n plus 1 derivative at some c value x minus a to the n plus 1 power over n plus 1 in parentheses factorial. We got to figure out what this is, worst case scenario. So essentially you're looking for the extreme value, max or min of this function, whichever is bigger absolute value, that's what you want. So I'm allowing you guys to approach this simply with a sketch. This is what this graph looks like. This is 2 pi, but then it gets divided by 3. This is pi, but then it gets divided by 3. So that's about 1. Now, we're going from 0 to 0.5. So 0.5 is right around here. Now, this is a little bigger than 1, right? 3.14. So that means that this is actually a little bigger than 0.5, and 0.5 is actually to the left of it. And so we're looking for worst case value from here to here, okay? Worst case value. And it doesn't, the amplitude is negative 243. But plugging 243 in is not correct. It doesn't quite get to 243, okay? The worst case scenario is plugging 0.5 into this function. So it's going to be negative 243 cosine of 1.5. No, sine of 1.5. Okay? Do not put 243 in. I mean, they might be really close. 243 sine of 1.5 is not quite 243. So your answer is going to be off. It's going to be wrong, but it's going to be wrong for a bigger reason, okay? Because you messed up with the value you chose. We're valuing at 0.5. The center is at 0. This would be fifth power over 5 factorial. So let's calculate that is. So we got that already. Times 0.5 to the fifth divided by 5 factorial gives you 0.0631227296. So our answer, let's say we're doing 3 significant digits, would be 0.0632 rounded. You could write it in scientific notation you want, 6.32 times 10 to the negative 2 would move it over. Okay? But that's what it's got to be. And you got to round up. Got to round up. Okay? Can't do 0.0631. So that's the Lagrange error bound. Number 5, find the Lagrange error bound for this function at x equals 2, whose Taylor polynomial is degree 3, centered at, okay. So n equals 3, that means we need to get n equals 4, the fourth derivative. So the zeroth term, the zeroth derivative is e to the x. First derivative is e to the x. This one's really simple. I'm going to show the work anyways because this is what I usually do. So fourth derivative is e to the x. That's what we're looking for. The Lagrange error bound is the absolute value of the n plus 1 derivative at some c value that makes it the worst case scenario, x minus a to the n plus 1 power over n plus 1 factorial. I like to just write that down. So for us, that means we're looking for the fourth derivative at a c value. We're evaluating it at x equals 2, and it's centered at 1 to the fourth power over 4 factorial. So worst case scenario, e to the x, you got to give me some evidence. You know, you could do EVT full blown if you want to justify it that way, but I'm letting you do this picture. It's going to be 1 to 2. Because remember, the c value is between the center and the value you're evaluating at. So the 1 and 2. 1 and 2, this chunk of the graph, worst case scenario is that one. So we're going to plug in e to the 2 And then we're multiplying times 1 to the 4th over 4 factorial. Well, that goes away. So it's e squared over 24. E squared divided by 24 is 0.3078773. Let's say we're doing 3 significant digits. It's going to be 0.308 for sure. No truncating, no rounding down, round up for max error estimates. So that's your Lagrange area bound. Number 6, let f be a function whose Taylor series converges for all the next derivatives are less than 2. Then what is its minimum number of terms? Taylor polynomial is centered at x equals 3, necessary to approximate 3.5, with an error less of that. So we're using Lagrange error bound. We might be able to simplify it first. So looking for the n plus 1th derivative at some c value, x minus a to the n plus 1 power over n plus 1 factorial. So for us, we know it's less than 2. Here, we're evaluating it at 3.5. It's centered at 3. We need to put the n plus 1 power there over n plus 1 factorial. So this is, it gets, it gets pretty simple, which I think helps. So if we did n equals 0, which would be 1 term, then L.E.B would be less than, you'd plug, it'd be 2 times 0.5 to the first power over 1 factorial. So that's just going to be 1, right? Which is that less than 0.002? No. So we'll go to the next one, n equals 1, which would be 2 terms. And L.E.B is less than 2 times 0.5 squared over 2 factorial, which is going to be 0.25. Is that less than 0.002? Nope. So we keep going. N equals 2, which is 3 terms. L.E.B less than 2 times 0.5 to the 3rd power over 3 factorial. So 2 times 0.5 to the 3rd power divided by 6 is 0.04166. Is that less than 0.002? No. But we're getting closer. N equals 3, which would be 4 terms. L.E.B is less than 2 times 0.5 to the 4th over 4 factorial. So 2 times 0.5 to the 4th divided by 4 factorial. 0.005208. Is that less than 0.002? No. I bet it's the next one, because we usually gain a whole digit every time. N equals 4, which is 5 terms. L.E.B is less than 2 times 0.5 to the 5th power over 5 factorial. Is 5.20833 times 10 to the negative 4th, which is the same thing as 0.0005208. Is that less than 0.002? Yes, it is. N equals 4, 5 terms. There you go. Back, we have some multiple choice problems, which just review some different stuff. So, what are the first 4 non-zero terms? The power series, e to the 4x, centered about that. Well, let's use the memorized version. It's Maclaurin series for e to the x. It's going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And then we're just going to plug negative 4x in there. wherever we see an x. And that should be the first four non-zero terms. Now, these are all simplified, so we got to simplify it. So it's going to be 1 minus 4x plus 16 plus 8x squared. This is going to be 4 times 4 is 16. It's going to be 64, so it's going to be minus 32 over 3x cubed. Do we see that? 1 minus 4x plus 8x squared minus 32 over 3x cubed. Here we go. Number 8, Taylor's series expansion of this about the point a equals 2. So this is the center. So I'm thinking we just got to work this out. So I'm going to build it. So the original function is this. The first derivative is going to be negative 1 over x squared. The second derivative is going to be positive 2 over x cubed. The third derivative is going to be negative 6 over x to the fourth. And then we're going to plug 2 into these. So we get 1/2, 1/4, 2 over 8, which is 1/4. But I think I'm going to try and keep thinking of it like that because I got to get a formula for this. Because on the top, those are just, I mean, you could reduce this to negative 3 over 8, but the top is, this is 0 factorial, 1 factorial, 2 factorial, 3 factorial. On the bottom is just 2 to the first, right? 2 squared, 2 cubed, 2 to the fourth. So I think we get a pattern easier that way. So the Taylor series is going to be 1 over 2 times x minus 2 to the 0th power over 0 factorial minus 1 over 4 x minus 2 to the first power over 1 factorial plus 2 over 8 x minus 2 to the second power over 2 factorial minus 6 over 16 x minus 2 to the third power over 3 factorial. So what's the general term? So it's alternating, so it needs a negative 1 to the n power. If we start at n equals 0, all these have n equals 0, then it's going to be that. It's going to be x minus 2 to the 0th power over to the n power over n factorial. This number right here is 2 to the n plus 1. On the top, though, we start getting a factorial. So there's another factorial on the top. That was 0 factorial. So that, and that's 1 factorial. So it matches up with the n value, which means these factorials cancel each other out. And I think we could write this best, n equals 0 to infinity of negative 1 to the n, x minus 2 to the n, over 2 to the n plus 1. I think that's going to be it. So there it is, answer A. But we kind of had to work for it. Okay, number 9, Taylor series, about, that's the center. When they say about something, that's the center, is given by this. What is the value of the third derivative? So we immediately go there because we know that 7 x minus 3 to the third power over 3 factorial would be the third derivative at 3 x minus 3 to the third power over 3 factorial. So I think this one, a lot of times the derivative might involve a factorial, but this one had the factorial already, so I think it's just going to be 7. That's it. Just a little more extra good practice for your test.